Hi and welcome. In this video, we're going to do some examples with function transformations, specifically related to graphing. So what I want us to do is apply the following transformations to the graph that we are given. So I'm just going to give us a graph of a function, and we're going to apply these transformations in the order that they're written. I wrote them in the right order, so this is the order that they should happen in, and we'll do them in this order. So for this first example, let's shift left by 2, then do a reflection over the x-axis, then a vertical stretch by a factor of 3, and lastly we'll shift down by 1. So you could try to kind of do these all at once to this graph, but I really like to do them one step at a time. So we're going to start with this half circle here, and I'll call this function k. So let's do one transformation at a time. First, we're going to shift k left by 2. So we basically just take our function and move it to the left by 2. If you ever need to, you can track specific points. So our points at -1 and 1 are now at -3 and -1. So we just subtracted 2 from both of them. This corresponds to being k of x plus 2. Remember, the input transformations are sort of weird. They're counterintuitive to what you would think, because what's actually happening is the axes are moving. So this is k of x plus 2, even though we subtracted 2 from the inputs. All right, next we do a reflection over the x-axis. So this is a vertical reflection, and we're going to just take all of the values that are above the x-axis and move them below. So I've just reflected this over, and this corresponds to -k of x plus 2. So we've taken those outputs and made them negative. All right, so that was our second transformation. Now we're going to do a vertical stretch by a factor of 3. So this means we take all of our outputs of our function, because we're doing a vertical stretch, and we're going to multiply them by 3. So where we have these points at 0, this -3, 0 and -1, 0, those points aren't going to move, since 0 times 3 is still 0. But our point at -2, -1 is going to move. We're going to move it to -3, since it's being multiplied by 3. So the -1 times 3 is -3. I think it's easier to just see it. So you can see we're taking this half circle and just stretching it by a factor of 3, so it gets 3 times taller. This then corresponds to -3k of x plus 2. So if you've watched the other videos in this sequence, you'll know that we can do the reflection or the vertical stretch in either order. So we could have done the stretch first and then reflected it, and we'd get the same graph. So I wrote them in this specific order, so that's the order we did them in, but you could have swapped these two transformations. All right, now we have our last transformation. We're just going to shift the graph down by 1. So all of the output values get moved down by 1, meaning we subtract 1 from them, and there we go. So this would be represented by -3k of x plus 2, all minus 1, and that -1 is the shift down. And there we go. That is our final transformed graph. All right, let's repeat this process on another example. So I'm going to give us a graph of g, and we're going to shift right by 1, then do a horizontal shrink by a factor of 1/2, and then a reflection over the y-axis. So I'm calling it a shrink here. In the past, I often also call this a compression, so these are the same thing. So a horizontal shrink or a compression by a factor of 1/2, followed by the reflection over the y-axis. So first, let's shift right by 1. This just means we take all of the inputs of our graph, all of the x values, and we're going to move them to the right by 1 by adding 1 to them. This is easier to see. We just take everything, move it to the right by 1. To write this out, we would write g of x minus 1. So remember, with the inputs, it's opposite of what you might think, so we actually do -1 to move it to the right by 1. Okay, next, let's do our horizontal shrink or compression that happens by a factor of 1/2. So to me, these are the hardest to do, so what I'm going to do is just pick some specific points and figure out what happens to them. So we have points at -3, 2, and at 3, 0. So these points are going to be multiplied by 1/2, specifically the input of 3 or -3 is. So if we have -3 and it gets multiplied by 1/2, this is now -3/2. So that point that was at -3/2 is now going to be at -3/2 2. So we take whatever it was and shrink it horizontally by a factor of 1/2. Same happens for the +3 point. That now becomes +3/2, and so we're shrinking it horizontally. Just to do 2 more points, if you look at the point at -1, 0 and 1, 3, these are now both going to get shrunk horizontally. So the -1 becomes -1 times 1/2, or -1/2, and the +1 becomes +1 times 1/2, or 1/2. So this is how I sort of track what is happening to do that horizontal compression. All of the inputs get multiplied by 1/2, and the outputs stay the same. Okay, so to write this, we would write g of 1/2 times x minus 1. So that x minus 1 stays in parentheses since we did that first, and then we take that result and multiply it by 1/2. So having all those parentheses is really important. We do g of 1/2 times x minus 1. All right, then our last transformation is a reflection over the y-axis. This is a horizontal reflection since it's happening over the y-axis. And so we're going to take all of the values that are on the left side of the y-axis and move them to the right, and all of the ones on the right side of the y-axis and move them to the left. So I'm just going to do that here. We're just going to mirror or reflect this over the y-axis, and we have my final graph. So to write this one out, we would have g of -1/2 times x minus 1. So that negative goes on the inside since we're doing a horizontal transformation or reflection, and that's our final graph and our final answer. All right, so those are 2 examples of how to apply transformations graphically. Thanks so much for watching, and I will talk to you in the next one.